Greetings to all those who are listening and watching. Welcome to the world of architectural acoustics. In this lecture series or video series, we will unravel the significance of acoustics in design, which would be catering to students, gate scholars, and practicing architects. So, from optimizing learning environments for students to aiding to their gate preparation, to master the architectural acoustics and ultimately guiding the fresher architects in real world applications. Our exploration in terms of the architectural acoustics covers it all. So join us as we delve in the fundamentals or methodologies or live case studies regarding the architectural acoustics that provide a concise yet comprehensive understanding. So whether you are a student or a gate scholar or a in a way fresher practicing architect, this journey into architectural acoustics would surely be promising the valuable insights for creating spaces that harmonize the functionality and aesthetics in context to the architectural acoustics. So I would like to let you know that this particular content is designed to give a snapshot of focus of architectural acoustics, and importantly, after attending this particular lecture, there is surety that your perspective towards the idea of architectural acoustics would surely be changed, and let us understand the details of architectural acoustics uh, through a very fundamental base, because whatever has been provided to you in this lecture or in this video series would be a very concise form of the matter or the theoretical knowledge that is present in the books that are related to the architectural acoustics. And I would like to let you know that the way the content is being provided to you would not be present anywhere on the internet, because I have tried to create a sort of singular line notes or notes with the bullet points that ultimately would be helping you to in a way understand the concept or the fundamentals of architectural acoustics in a very concise way. And I would be forming a theoretical base of the science that is attached to the architectural details of that particular area, which means that I would be starting with the understanding of sound. And as far as the whole idea of physics is concerned, it would be explained in detail in this lecture series. So ultimately, this lecture and this video would be helpful to you to understand the details and basics and fundamentals of architectural acoustics in a very concise and organized pattern. So let us start this lecture with the understandings of physics of sound, which would eventually be helping you to learn about the interrelationship of physics of sound to the details or the fundamentals of architectural acoustics. So now it is important for us to understand the physics related to sound. Uh, so we shall be starting with the basic definition of sound, which says that sound is a captivating sensation and is auditory experience perceived by human ear, which helps you to understand that the basic idea behind the development of sound is that कि एक तरीके से सेंसेशन होता है जो कि ऑडिटरी एक्सपीरियंस में कन्वर्ट होता है और जिसको आप थ्रू ह्यूमन ईयर परसीव कर सकते हैं. इट वुड बी ए ट्रांसफर ऑफ एनर्जी from source to the receiver, which we discussed in the last lecture that is already available on this channel. If you want to learn about the concept of transfer of energy and formation of crest and trough, you may go to that particular video, the very first video on this channel. So ultimately, the sound is basically a sensation that has been experienced or auditory experienced by human ear through the transfer of that energy from that particular source, and it is a result of rapid fluctuations in air pressure, often orchestrated by vibrating objects. So by vibrating objects, what we are doing is that we are creating that energy, and that energy is transferred in the form of in a wave, and that wave would be called as a longitudinal wave, which is having some sort of amplitude attached to it, and there would be formation of crest and then trough. So I have already explained this concept of crest and trough, and I shall be repeating it in a very quick way, that this upper portion above this axial line would be called as crest, and this lower portion would be called as trough. So there would be formation of crest and trough, and that is how the sound would be propagating in the direction that is being happening. And then ultimately the distance between the midpoint of maximum point of the trough or the crest would be called as the wavelength, and then it is denoted by the sign lambda, and that is what we have to remember. And then moving on, the essence of sound lies in the creation of waves through the longitudinal motion of air. The longitudinal motion means that wherever the particles are present in that particular medium, those particles shall be moving with the direction of propagation of wave. See, there are two kinds of wave. One is the longitudinal wave and the other one is the transverse wave. So what is happening in the longitudinal wave is that the particular particle that is present in that medium is moving within the direction of that propagation of wave. Whereas in case of transverse wave, the particle that is present in that medium is moving perpendicular to that particular direction of propagation of wave. So that is the basic difference between the idea of transverse wave and longitudinal wave. हमें इस चीज का ध्यान रखना है that the waves that are traveling in the context of sound are longitudinal waves. First of all, air particles के अंदर जब वो travel करती हैं तो longitudinal waves का formation होता है. उसके बाद हमें ये पता लगता है कि vibrating objects set the air molecules in motion, generating a rhythmic pattern of compressions and rarefactions. This formation of crest and trough is called basically as the compression and rarefaction. So the compression and rarefaction is happening when the particles or molecules that are present in the particular medium through which the sound is traveling are in a way forced to get into the motion. And then moving on, it becomes important to understand the analogies to the wave motion. So when we take the idea of rippling or the concept of ripples or the formation of ripples in water or pond surface, the ultimate formation of the longitudinal nature of sound resembles the idea of formation of ripples in the water. So the concept behind the formation of ripples is that whenever you throw any object or any pebble in the pond or any water body, there tends to form these circular structures or formations around that drop, and then ultimately the molecules present in that water tends to show some sort of motion in that context. So what you experience in that context is that the water is moving in the direction perpendicular to that particular wave. So that is how you tend to experience that ripple. But whereas in case of the sound, the particular particle is traveling with the direction of that sound, so you're not able to see of what ripple effect is in the context of air. So both phenomena exhibit a graceful propagation of wave emanating from their source at a constant and mesmerizing pace. So, and then ultimately this diagram helps you to understand that at a medium or any kind of receiver, when a sound wave gets to attached it in a way either reflects back some of the particles and or absorb some of the particles that are present, and then thirdly transmits some of the particles. So three processes are happening whenever a sound wave strikes any particular medium or any object or any kind of receiver. The first one that would be taking place would be the reflection of particular particles, and then the absorption of particles would be taking place, and then thirdly the transmission of particles would be taking place. So this whole concept would be the base of architectural acoustics, because जो भी आप material या जो भी आप typology of volumetric mass अपने रूम या पर्टिकुलर स्पेस के अंदर इंस्टॉल करते हैं, उससे अटैच्ड प्रॉपर्टी जो है वो इन्हीं तीन कॉन्सेप्चुअल आइडियाज पर बेस्ड होती है. आइदर इट वुड बी रिफ्लेक्टिंग दैट पर्टिकुलर साउंड और एब्जॉर्बिंग दैट साउंड और ट्रांसमिटिंग दैट साउंड्स. तो एक रूम को या एक एनवायरनमेंट को या किसी भी एक पर्टिकुलर स्पेस को आर्किटेक्चरली अकाउस्टिक्स में इम्प्रूव्ड बनाने के लिए इन्हीं तीन तरीकों में आपको ध्यान रखना होता है कि वो काम करे, दैट इट इज वेल एब्जॉर्बिंग आइदर फर्स्ट ऑफ ऑल, सेकेंडली इट शुड बी रिफ्लेक्टिव. कई कई बार ऐसा भी होता है कि आपको कहीं मटेरियल ऐसे इस्तेमाल करने पड़ते हैं जिनकी रिफ्लेक्टिव प्रॉपर्टी बहुत अच्छी है, एंड देन ट्रांसमिटिव प्रॉपर्टी भी इंपॉर्टेंटली उतना ही अच्छा रोल प्ले करती है. सो दैट इज द होल बेसिक of or the fundamental of physics of sound that helps to set the base of the architectural acoustics in any particular space. And then moving on, we tend to understand that the wave that is traveling in the medium of air tends to have some sort of elasticity attached to it. The elastic wave exhibiting in medium with mass and elasticity showcase the intricate dance between the molecular forces. एंड इलास्टिसिटी से हम समझते हैं कि कोई भी एक पर्टिकुलर पार्टिकल जिस जगह से उस पर मोशन लगने के बाद वो जगह छोड़ करके उसी पर्टिकुलर जगह पर वो वापस आ जाए, दैट मीन्स दैट पार्टिकल इज इलास्टिक. जैसा कि आप रबर बैंड के एग्जांपल में सीखते हैं ना कि आप उसको एक्सपैंड करते हैं, लेकिन आउट ऑफ सम नेचर ऑफ इट्स ओन इट्स टेंड्स टू गेट टू इट्स ओरिजिनल शेप. So that property by virtue of which that particular particle is coming back to its shape is called as elasticity. तो जो फिजिक्स या साइंस है साउंड की वो हमें ये समझाती है कि साउंड के अंदर जो पार्टिकल्स होते हैं उनके अंदर भी इलास्टिसिटी का कुछ ना कुछ एलिमेंट देखा गया है, एंड देयर इज ऑलवेज प्रेजेंस ऑफ मास, बिकॉज आइदर जब उस केस में मॉलिक्यूल्स प्रेजेंट हैं तो उस पर्टिकुलर वेव के अंदर मास का होना लाजमी बात है. सो फर्स्ट ऑफ ऑल वी हैव टू अंडरस्टैंड दैट देयर वुड बी मास अटैच्ड एंड देन इवेंचुअली इट वुड बी इलास्टिक इन नेचर. सो मूविंग ऑन, वी टेंड टू अंडरस्टैंड दैट द डिस्प्लेस्ड पार्टिकल्स ट्रांसफर momentum to neighboring particles, allowing initial disturbance to ripple throughout the entire space. So this is the diagrammatic formation of ripple. So जब आप sectional form में समझें तो that is how a ripple is formed. जो वाटर के पार्टिकल्स हैं वो डायरेक्शन ऑफ वेव के परपेंडिकुलर कुछ इस तरीके से मूव करते हैं, और ऑन द सरफेस ऑफ वाटर यू टेंड टू एक्सपीरियंस दिस काइंड ऑफ रिपल. एंड विच सेज कि मान लीजिए एक पॉइंट ऑफ सोर्स से एनर्जी की शुरुआत हुई, तो वो पर्टिकुलर एनर्जी इस पर्टिकुलर मॉलिक्यूल या मैटर पर लगी. सो अब क्या होगा कि ये जो डिस्प्लेस्ड पार्टिकल है एनर्जी लगने की वजह से ये ट्रांसफर ऑफ मोमेंटम करेगा टू दी सेकेंड अटैच्ड और नेबरिंग पार्टिकल्स, एंड दैट इज हाउ दैट मोमेंटम वुड बी ट्रांसफर्ड टू दी अदर नेबरिंग पार्टिकल्स और the next neighbors and next to next neighbors, and that is how the wave would be traveling in any of the medium, be it the air medium or the water medium, in a way vacuum, or it could be liquid or it could be solid. So the formation of that particular ripple is helping us to understand that there would be transfer of momentum to the neighboring particles, and ripple would be formed out of that transfer of momentum in the entire space. And analogies with ripples helps to understand that whether the wave is traveling in air or in water, there would be exchange of momentum without no net transfer of matter, which means that मोमेंटम उसके अंदर होगा, उस मोमेंटम का ट्रांसफर होगा जो कि एक पार्टिकल से दूसरे पार्टिकल पर अप्लाई होगा, लेकिन इंपॉर्टेंटली नो नेट ट्रांसफर ऑफ मैटर वुड बी देयर, दैट जो एनर्जी आपको यहाँ से जिस सोर्स से मिली थी, जहां से आपने शुरुआत की थी, वहां से शुरू होने के बाद अल्टीमेटली जिस रिसीवर पर वो एंड होगी, वहां तक देयर वुड बी नो नेट ट्रांसफर ऑफ मैटर. And that is how the scientific base of the conservation of momentum comes in. हम उसके in depth में नहीं जाएंगे. It is important just to understand that there would be the presence of momentum and ultimately no transfer of matter would be happening. And then lastly, while ripples on a pond surface manifest as transverse waves, sound in air takes the form of longitudinal waves, जो कि मैंने आपको लास्ट स्लाइड में समझाया था कि वाटर के अंदर जब वेव्स ट्रैवल करती हैं या किसी भी तरीके का एक तरीके से एनर्जी का ट्रांसफर होगा, तो दैट वुड बी ट्रांसवर्सल वेव इन नेचर, विच मीन्स कि जो पार्टिकल हैं उस मीडियम के, वो प्रोपगेशन ऑफ वेव के परपेंडिकुलर ट्रैवल करेंगे. इफ दिस वुड बी द प्रोपगेशन ऑफ वेव्स, then the particles would be traveling in this particular direction. Okay, and in case of the longitudinal waves, the particles would be traveling in the direction of wave, and that is how you could see the direction of particle motion. So this particular length of that crest or trough in which the motion of that particle is happening would be called as amplitude. So to extent of what height this crest is formed would be called as the amplitude, and to the depth to which the trough is formed would be called as the amplitude of that particular wave. So as of now, we have understood of what the wavelength is, of what the amplitude is, and how that particular sound wave would be traveling. And from this slide we understood that there tends to have the attachment of elasticity and presence of mass with that particular particle that is present in that medium. And then secondly, there would be the idea of transfer of momentum from one particle to the neighboring particle. And thirdly, there would be difference between the transversal waves and the longitudinal waves, based on the fact that the longitudinal waves would be having the particles that are moving in the direction of that particular propagation of wave, whereas in the case of transversal waves, the particle would be moving perpendicular to that propagation or direction of that particular wave. So that is what is there in this slide. So now continuing with the furthermore ideas, we shall be understanding of what the particle velocity exactly is, because जितने भी particles travel करते हैं, जो कि हमने समझा था कि जब भी एक wave बनती है तो it always travels in the form of particles. So that particle tends to have some sort of velocity attached to it. And जो हमने दो criteria समझे थे, the one was the transverse criteria and the other one was the longitudinal criteria. So importantly, in transversal waves, particle velocity occurs at right angle to the direction of propagation, importantly, whereas in the case of the sound waves, because they are the longitudinal waves, it aligns with the direction of propagation. So ये फैक्टर सीखना बड़ा ज़रूरी है कि जो भी पार्टिकल मूव करता है, that propagates with the direction of that wave, particularly in case of the sound waves. So the velocity for that particle would be similar to that of that particular wave. And in case of transverse wave, it would eventually become the velocity perpendicular to that particular wave or that particular crest or trough. Because in transversal waves, the particle velocity occurs at right angle. And when we move forward, we understand the continuous fluid model, which says that a particle of medium represents a volume element with millions of molecules, allowing us to treat it as a continuous fluid, which with the consistent acoustic variables. So which says कि जितना भी आपका flow होता है in terms of the wave motion, that tends to have some sort of volume attached to it. In case वो air में move on कर रहा है तब भी वो एक इनविजिबल तौर पर एक वॉल्यूम होता है, बिकॉज लास्ट स्लाइड में हमने समझा था कि जहां पर भी वेव ट्रैवल करती है वहां पर उस पर्टिकुलर पार्टिकल के पास एक मास होता है. So in case mass is available, so it becomes important that the volume element would also be there with the millions of molecules, which allows us to treat it as continuous fluid. So scientifically, it could be said that whatever has been traveling with the propagation of wave tends to have some sort of continuous fluidity in it. So moving on, when we talk about the wave velocity, so wave velocity is the velocity with which the wave travels in a medium, and particle velocity is the one with which the particle moves on. Wave velocity is velocity of transmission of wave, whereas the particle velocity is velocity of particle that is moving with or perpendicular to that direction of particular wave. So it makes the conceptual idea clear that there is presence of particles in the direction of wave whenever it is the sound wave, और अगर वो transverse wave है because sound wave is longitudinal wave, तो transverse wave में वो जो particle है वो perpendicular तौर पर move on करता है, whereas in the case of longitudinal it would be with the direction of wave. There would be availability of velocity attached to that particle. There would be some sort of volume attached to it, and that is why a continuous fluid would be made. And then when we do the propagation comparison, whether it's ripples on a pond or resonance of a sound, both travel gracefully sustained by exchange of momentum, which we learned in the last slide कि जब भी particles एक तरीके से निकलते हैं या छूटते हैं एक particular source से, तो due to presence of energy and mass, there tends to have some sort of momentum attached to that particle, which is being transferred to the neighboring particle. So that is why it is being said that जो propagation है वो चाहे एक तरीके से sound के motion में हो या sound की wave में हो या otherwise वो water वाली wave में हो which is in pond, दोनों cases में एक graceful travel होगा और which would be sustained by the exchange of momentum or transfer of momentum to the neighboring particle. So that is how the motion or propagation of a wave works. And then the key distinction out of this whole fundamental idea would be that ripples on a pond are transversal waves painting a visual spectacle. On the other hand, sound in the air waves its story through the medium as longitudinal waves, creating a symphony for our ears. So अब तक जितना हमने पढ़ा है या समझा है इस फंडामेंटल आइडिया में, वो ये है सबसे पहली बात कि साउंड जो है वो लॉन्गिट्यूडनल वेव के तौर पर ट्रैवल करती है, पहली बात. दूसरी बात, देयर आर फॉर्मेशंस ऑफ क्रेस्ट एंड ट्रफ which tends to help us to calculate the wavelength and amplitude of that particular wave. And then thirdly, it has been compared to the formation of ripples in case of pond whenever we throw any pebble or any sort of object in it. So that is how the very basic idea of propagation of wave is formed. And then ultimately we learned about the concept of velocity and momentum attached to the particle that is being traveling through and through with the propagation of wave. So this short discussion tends to set the base for the upcoming video series, which would be about the frequency, the amplitude, the intensity, and the decibel calculation of that particular sound wave. Because the one who is not aware of how a sound travels would not be able to understand of what happens in terms of the frequency or calculations of intensity, and furthermore calculations That is why it is very important to at least understand of how the physics of sound is being initiated with the basic or fundamental ideas, because it tends to set the concrete base to understand or to learn the architectural acoustics in detail. So in this lecture we have this much discussion only, and in the upcoming lecture we would be discussing about the, as I told you, the frequencies and the intensities attached to the sound wave, because now, as of now, you are now ready to at least learn or to tell other peoples about the idea of how a sound wave travels or how a sound wave is formed ultimately, which is based on a scientific fact. So thank you so much for watching this video, and I hope it was informational to you. And in case if you have liked the video or the way the content has been presented to you, please let me know with the comments. And in case if you think that there could have been some sort of improvements with the content that you are getting, then also please let me know, because eventually that would be helping me to provide you the desired content which you think would be there. And that is all for today. Thank you so much for being a part of this video, and we shall be continuing with the details of frequencies, intensities, and furthermore calculations related to sound. I'm always open to whatever you all put up as a viewer. So in case you have any sort of inferences after watching this video, please let me know about it, and feel free to reach to me through this YouTube channel. And thank you so much for being here. And that is all we have for today in this class. Thank you.